Hello everyone, welcome back to our channel. In today's video, we will be discussing about measures of central tendency. Now, what is measures of central tendency? Now, measures of central tendency provide a summary measure that attempts to describe a whole set of data with a single value that represents the middle or center of its distribution. And there are three main measures of central tendency. We have the mean, median, and the mode, and we are going to discuss one by one. Now we're gonna start with the mean. Now what is the mean? Okay, so let's start with the key concepts. The mean is the arithmetic mean, or simply the mean of a data set, is the sum of the values divided by the number of values. So if x sub n, x sub 2, x sub 3, and so on and so forth until x sub n are individual scores in a population of size n, then the population mean is defined as mu is equal to the summation of x sub I all over n. Mu is actually a Greek letter alphabet. It's a lowercase Greek letter alphabet that symbolizes or represents mean. Now let's have an example. So, for instance, the systolic blood pressure of 8 patients taking antihypertensive drugs recorded as 90, 86, 70, 100, 110, 175, and 83. Now, if we are asked to find the mean, all we have to do is we are gonna add all we're going to get the sum of the data. So we have this one, we have 90 plus 86 plus 70 plus 100 plus 110 plus 100 plus 75 plus 83 all over how many number of observations? We have 8. So we'll divide it by 8, and so we have 714 divided by 8. That gives us 89.25. So basically that would be our mean. Okay, let's proceed to another example. On the other hand, if x sub 1, x sub 2, x sub 3, and so on till x sub n are individual scores in a sample of size n, then the sample mean is defined as sample mean is equal to the summation of x sub I over n. So that would be the symbol for sample mean. So the solution would be like that. The same given, however, we just use the different symbol because we're talking about the sample mean. So we have that, and the mean is 89.25. We just simply use instead of mu, the lowercase or the lowercase of Greek alphabet. So we use that symbol for mean. Now let's have an additional example. For instance, the cholesterol counts of a sample of 6 patients are recorded as follows. We have 124, 214, 175, 200, 198, and 211. So find the sample mean of this data. So let's proceed to the solution. So you have here, since we are asked to use the sample mean, we will be using that symbol, the X with a bar on top. So you have it there. All we gonna do is add and then divide it by the number of observations. So you have 122 plus 214 plus 175 plus 200 plus 198 and 211 divided by 6. So that gives us 1120 divided by 6, and that is equal to 186.67. So that would be our mean. Thus, the mean cholesterol count for the 6 sample patients is 186.67. Okay. that was the previous examples were for ungrouped data, meaning ungrouped data, they are not yet arranged, they are raw data. Okay, so now let us proceed to the mean of group data. And when I say group, of course, it is the opposite of ungroup. When you say group, the data are already arranged in a frequency distribution table. So let's take a look at how are we going to solve for the mean of group data. So let's have an example. So for group data which are placed in FDT or frequency distribution table, the mean can be approximated using the formula. So you have it here, mean is equal to the summation of fx over n. Or you can have the mu, or that's still the population mean is equal to the summation of fx all over n. Okay, so that's the formula for the population mean and the sample mean. Again, for the sample mean, you have there the x with bar on top. You're gonna use that one. It depends on the data given. And you have that. Okay, so you have sample mean, and the mu is the population mean. F refers to the frequency of a class, and then X is the class mark of a class. Okay. Then N is the sample size, while the capital letter N is the population size. Then let's proceed to the example. Okay, for a moment. So the mean for ungrouped data is just very simple. However, this one, it's just still simple. However, we are dealing with the frequency distribution table. Now, let's have the first example. Now, let's have an example for the mean. Consider the sample frequency distribution table of the urine amylase of 15 patients. Now, we're talking about amylase here. By the way, the amylase is actually an enzyme that helps digest carbohydrates. Now, we're trying to integrate health or science in the fields of mathematics. So, if ever the results show an abnormal level of amylase in your blood or urine, it may mean you have a disorder of the pancreas or other medical condition. High levels of amylase may indicate like acute pancreatitis or a sudden and severe inflammation of the pancreas. Okay, so let's go back to our topic. So we have here the frequency distribution table. We have the first column classes, and then the second column we have the frequency. So we're gonna add one more column. So rewriting the classes, the frequencies, and X out the frequency, the total number or the sample, the population size is 15, or the sample size is 15, and we're going to get the class mark. We actually added two more columns, sorry. So we have here how to get the class mark or X. So all we have to do then is we are going to focus our attention on the first column first, and we're gonna start at the bottom. Actually, we can start from the top, but here we're gonna start from the bottom, 10 to 19. So in that particular class size or class interval, 10 to 19, so we're gonna add the upper class boundary and the lower class boundary, that is 10 plus 19, that will give us 29. Then 29 divided by 2, that will give us 14.5. Next, 20 plus 29, that will give us 49. And divide it by 2, that will give us 24.5. We'll do the same process 30 plus 39, that will give us 69, divided by 2, that will give us 34.5. The same procedure, 40 plus 49 is 89, divided by 2, that is 44.5. Then we also have 50 plus 59, that's 109, divided by 2, that is 54.5. Okay, so it's just very simple for us to provide the third column as our class mark. So that is just how we are going to solve for the class mark. Now, for the fourth column, we have their fx. So basically, and obviously, we're just going to get the product of our frequency with our class mark. So that is 5 times 14.5, that gives us 72.5. 4 times 24.5, that's 98. Then 3 times 34.5, that gives us 103.5. Then 2 times 44.5, that gives us 89. And 1 times 54.5, that gives us 54.5. Okay, what's next? So the next thing that we're gonna do is we're gonna add the summation of fx. So we're gonna add the numbers in the fourth column. So we have 54.5 plus 89 plus 103.5 plus 99 plus 72.5. That will give us the summation of fx, which is 417.5. Okay, and then going back to the formula, we have the sample mean is equal to the summation of fx over n, or then we have 417.5 over 15, because our summation of fx is 417.5 and our n is 15, and that gives us 27.83 as our sample mean. Okay, I hope everything is clear so far. Okay. Now let's proceed to the next measure of central tendency, and that is the median. Okay. So same with the mean, we're gonna start solving the median from ungrouped data, meaning from raw data. So let's start with the key concepts. So we have here the median, denoted by MD, is the middlemost value when the observations are arranged either in ascending or descending order. So we have here considered the results which represents the scores of 11 students. Okay, so that is raw data. You have 43, 32, and so on. And then all we have to do is putting the scores in an array, or meaning in arranged manner. So now we have 25. In this manner, it is arranged in ascending order. We start from lowest to greatest. So you have 25, followed by 28, 31, 32, 36, 38, 42, 43, 45, 72, and 84. The next would be, we are going to locate the middlemost value or number. So we have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Since the number of cases or observations is an odd number, it's easier for us to locate the centermost or middlemost number or value, and that is 38. Therefore, our median is 38. Okay, very simple. Now let's proceed to the next. Note, if the data has even number of observations, then the median is the average mean of the two middlemost values. So it's easy if it's an odd numbered observations. However, if it is an even numbered observations, all we have to do is we're gonna add the two middlemost numbers or observations, then we're just going to get the average, or add the 2, then divide it by 2. Okay, So let's have an example with a median of a raw data with even number of observations. So suppose we have the data of the number of outpatient department from day 1 to day 6. So day 1 to day 6, that is our first column, and the number of patients per day in the second column. Then putting the scores in an array, or we are gonna arrange it in ascending order. So we have 1,000 followed by 1,800, 2,400, 2,600, 4,500, and 5,300. So 1, 2, 3, 4, 5, 6. We have 6 observations all in all. So what we're going to do now is we are going to encircle the 2 middlemost observations, and then we're gonna add the 2 figures. So we have 2,400 plus 2,600 all over 2. That gives us 2,500, and that will be our median. Okay. Now let us proceed to the median of group data. Now this time we will be dealing with frequency distribution table again. So let's start with its formula. Okay, so we have here the formula of the median for the group data. We have MD stands for the median class. Then we have LCB sub MD, that is read as, or that represents lower class boundary of median class. C is the class size, and the less than cumulative frequency with pre at the or sub pre, we have that less than cumulative frequency preceding the median class. Okay. And the median class, okay, for a moment, and for the median class, it is the class where the less than cumulative frequency is greater than or equal to n over 2 for the first time. Because it is very important for us to locate the median class. Okay? So you have to remember that the median class again is the class where the less than cumulative frequency is greater than or equal to n over 2 for the first time. Remember, n is your sample size. Then divide it by 2. Then after that, we are going to look at the less than cumulative frequency. Okay. So let us again consider the frequency distribution table of the urine amylase of 15 patients. Okay. Considering that data, we have the classes and the frequency. Now we're gonna add one more column to get the less than cumulative frequency. We set the classes as the given and also the frequency. And how are we going to get the less than cumulative frequency? This is now the procedure. First and foremost, you're gonna start from the bottom, and you're going to look at the, focus your attention at the frequency, the second column. Then write first the first number, or the frequency at the bottom part is 5. So you just write first 5 under the less than cumulative frequency column. And then 5 plus 4. 4 is the frequency next above 5. So you have 5 plus 4, that gives you 9. Then 9 plus 3, that gives you 12. Then 12 plus 2, that gives you 14. Then 14 plus 1, that gives you 15. Okay? Were you able to follow? So again, you just copy first the last frequency for your less than cumulative frequency, then just add to the next frequency and do the same procedure as you go along. Okay. Therefore, okay, for a moment. Okay, so you have here, let's get first all the data so you'd understand it better. So, now for a moment, let's go back. You have the classes, you have the frequency, you have the cumulative frequency table. Okay, so that is your median class. And then, okay, okay. So for you to locate your median class, you have there n over 2. Then your n is 15, right? Your sample size is 15, then divided by 2, that gives you 7.5. Then it states there that for you to locate the median class, you need to look at the less than cumulative frequency. The first value in the less than cumulative frequency column that is greater than n over 2 for the first time. So it falls on 9. Okay? Then we're going to enclose. That would be our median class. So our F or frequency would be 4. We're trying to get the data from the median class, meaning the frequency of the median class is 4. And then our C or our class size is 10. And where do we get 10 as our class size? So take a look at the classes. You have 20 to 29. If you're going to count 20 to 29, you have 20 to 29, that gives you 10. You include 20 in your counting. Okay? Then you also have the lower class boundary of the median class is 19.5. How do we get 19.5? So we have it here. In our median class, we have 20 to 29. To get the lower class boundary of our median class, all we have to do is we're going to look at the lower class boundary, which is 20. The upper class boundary is 29. But we are considering the real class boundary or real class limit. So we are going to subtract 20 by 0.5. So that gives us 19.5. Then, going back to the formula, we have the median is equal to the lower class boundary of the median class plus the class size times the quantity of n over 2 minus the less than cumulative frequency of the preceding class over the frequency of the median class. Okay. Therefore, you have it here. So we're going to substitute now the values of for our median. So you have here our lower class boundary of the median class is 19.5. Then our class size or class size is 10. Our n over 2 is 15 over 2, and that gives us 7.5. Then minus the less than cumulative frequency of the preceding class, meaning the less than cumulative frequency before or below the median class is 5, then over the frequency of the median class, which is 4. Then let's manipulate the formula now. You have 19.5 plus 10, 7.5 minus 5, that gives us 2.5, then divided by 4. So you have 19.5 plus, you have 10 times 2.5, that's 25, divided by 4, and then you have 19.5 plus 6.5. Then our median is 25.75. Okay. So I hope that solving for the median for the group data is clear. So that is the process on how to solve the median in a frequency distribution table. Okay, let's proceed. Now let us proceed to the mode. Okay, what is mode? So let's start with the key concepts. The mode denoted by MO is the value when in the data set that occurs most frequently. Or the mode is easy to determine because one has just to count the frequency of each score and find the score with the highest frequency of occurrence. So it's very simple for us to spot the mode in an ungrouped data. So let's have an example. So let's start with the mode of ungrouped data. So consider the following data set whose values represent the IQ scores of psychiatric patients. So the data set A, we have 77, 83, 91, 85, 83, 100. And the data set B, we have 88, 92, 71, 88, 71, 36. And the data set C, we have 96, 43, 79, 68, 83, 110. So what is the mode for set A? So kindly examine the data in set A. What do you think is the mode? Okay, let's check. What's the mode? So our mode is 83 because 83 appears twice in the data set A. Okay. What is the mode for set B? Okay, you have there 88 appears twice. However, we also have 71 that appears twice. So both 71 and 88 appears twice in the data set B. So our mode would be 88 and 71. So if we have two modes, we call it bimodal. Okay? And if we have if we have three modes, we call it trimodal. And if it's more than three modes, we call it multimodal. What is the mode for set C? Given the data, we have 96, 43, 70, 79, 68, 83, and 110. So there's none. There's no mode in data set C because each observation do not repeat or does not repeat, I mean. Okay, now let us proceed to the mode for group data. Now, for group data, the mode can be approximated by using the formula. Okay, so you have it there. The formula for the mode is, you have the formula on top for the mode, and you have the C stands for the class size. Then F sub MO stands for frequency of the model class. Then F1 stands for frequency of the class preceding the model class. Then F2, frequency of the class following the model class. Then we have also the lower class boundary of model class. And the model class is the class which has the highest frequency. So the first thing that we are going to do when trying to solve for the mode of group data is we need to locate the model class. And in order for us to locate the model class, we will just going to look at the class which has the highest frequency. So let's have an example. Consider the frequency distribution table below. We have the set of classes, then the frequency. So basically, our model class, which has the highest frequency, our highest frequency there is 8. So our model class would be 30 to 39. Okay. Then now, the lower class boundary of the model class, as I've told you, for the same is true for the median. We're just going to subtract the lower class boundary with 0.5. So that's 30 minus 0.5. That gives you 29.5. And our frequency of the model class is 8. And our C, or the class interval, is 10. Our F1, or the preceding frequency of the model class, is 6. And F2 is the frequency after the model class is 4. Okay. And now we are going to substitute the values. We have your mode is equal to the lower class boundary of the model class plus the class interval times the quantity of the frequency of the model class minus the frequency of the preceding class, and all over 2 times the frequency of the model class minus the frequency of the preceding class minus the frequency of the class after the model class. So substitute all the values. So mode is equal to 29.5 plus 10 times the quantity of 8 minus 6 all over 2 times 8 minus 6 minus 4. Then we have mode is equal to 29.5 plus 10 times, you have 8 minus 6, that's 2. 2 times 8, that's 16. Then negative 6 minus 4, that's negative 10. So our mode is 29.5 plus, you have there at the denominator 16 minus 10, that's 6. So you have 29.5 plus 10 times 2 over 6. Then mode is 29.5 plus 10 times 2, that's 20, all over 6. Then we have 29.5 plus 20 divided by 6 is 3.3. And our mode is 32.8. Okay. I hope that you were able to follow our procedure on how we are going to get the mode for group data. Okay. So since I have given you already the examples in solving for the mean, median, and mode for both ungrouped and grouped data, now let's try to check as to whether or not you have learned something from this video. So let's have an evaluation. So we have number 1, compute the mean, median, and mode in each of the following data sets. Show solution. Your data set given, so here we're just going to use one data set and you will be solving for the 3 measures of central tendency, that is mean, median, and mode. You have 48, 65, 52, 48, 83, 55, 64, and 26. So you are going to get the mean, median, and mode for that ungrouped data. Okay. So for number 2, approximate the mean, median, and mode given the following frequency distribution table and show your solution. So you can add the necessary columns, especially if you're looking for the mean, the median, and the mode. So just add the necessary columns for you to get the necessary values so you can make use of the formula afterwards. So you have 30 to 32, 27 to 29, 24 to 26, 21 to 23, 18 to 20. And for the frequency, you have, for the frequency column, you have 4, 1, 2, 3, and 6. Okay, so that would be all for your evaluation part. I hope that you can answer this set of sort of comprehension check. Okay, I hope you're enjoying our discussion today. So before I'm gonna end this video, I have here a quote. Math can be related to our lives. It teaches us to always be careful with the signs. It's applicable. This quote is applicable when you are in a relationship. So the signs would help you when to give up and when to still hold on. Okay, so thank you so much for watching, and don't forget to subscribe our channel, and that would be all for today. Bye.